Hi students, in the last lecture we see theorem of composite functions. For composite function means functions of another function. Now we see exercise 1.1. So first one example is there. Y is equal to x cube minus 2x minus 1 bracket raised to 5. That is function raised to another, that is function of function. It is called as composite function. First example we solved by two methods. First one is by chain rule, or it is called as composite function theorem. On second method directly we solve this example. So what is given? X cube minus 2x minus 1 raised to 5. So first try to solve by chain rule. So first consider u is equal to x cube minus 2x minus 1. So now this y is equal to what? If we take u is equal to this term, then our function y is equal to u raised to 5. So here now y is a function of u. So differentiate with respect to u. Differentiate with respect to u. Therefore, derivative of y with respect to u is dy upon du. Now derivative of u raised to 5 with respect to u, that is 5 into u raised to 5 minus 1, which is equal to 5 into u raised to 4. But what is our u? Put this function here. U value of u is x cube minus 2x minus 1 bracket raised to 4. This is dy upon du. Now here we consider u is equal to x cube minus 2x minus 1, but u is a function of x now. So differentiate with respect to x. Let u is equal to, we consider x cube minus 2x minus 1. So differentiate with respect to x, because now this u is a function of x. So derivative of u with respect to x is du upon dx, which is equal to, now tell me derivative of x cube, that is 3x square, minus derivative of 2x, which is constant, so minus 2, and derivative of minus 1, this is constant term, so derivative of 1 is 0, which is dv upon dx. So by using chain rule, in last theorem we studied, therefore by chain rule, what is chain rule? Dy upon dx is equal to what? Dy upon du into du upon dx. So from 1 and 2, from 1 and 2, dy upon dx is equal to, first term is dy upon du. So put here value of dy upon du, that is 5 into x cube minus 2x minus 1 raised to 4. That is first equation. And what is second? 3x square minus 2. 3x square minus 2, which is solved by using composite function theorem or by using chain rule. Now we can solve this example by direct method. So how we solve? Which is our first method. That is first method. Now we are going to start this example solved by using second method. So how to solve the second method? Directly we solve this. Now by second method, y is equal to, we have given that term, that is function raised to 5. So differentiate with respect to x. Differentiate with respect to x. Therefore, derivative of y is dy upon dx. Sorry, that is derivative of x cube minus 2x minus 1 raised to 5. So, what is derivative? So, consider this as a function. So, consider in mind that is it is only x. So, what is derivative of x raised to 5? That is 5 into x raised to 4. So 5 into x. X means whole this term. X cube minus 2x minus 1 raised to 5 minus 1. So it becomes 4 into, take a derivative, multiply the derivative of this function. Now this is not only x, this is our f of x. So here take a derivative of x cube minus 2x minus 1. So this term as it is x cube minus 2x minus 1 into, now write the derivative of this function. So what is derivative of x cube? 3x square minus derivative of 2x is 2 and derivative of 1 is 0 since it is constant term. So we get the final derivative dy upon dx is equal to 5 into x cube minus 2x minus 1 raised to 4 into 3x square minus 2. These both answers are same. So we can find any method. We try to solve by chain rule or we are going to try by second method. Both methods are very interesting and easy. So we have here we are going to solve by using our first method, which is straightforward. Now second example is there. Second, y is equal to what? 2x raised to 3 by 2 minus 3x raised to 4 by 3 minus 5 raised to 5 upon 2. Now we are going to solve directly. So consider in mind this is our x. So here again x raised to 5 by 2. So how we find the derivative? By power function. So write first differentiate with respect to x. Differentiate with respect to x. So dy upon dx is equal to derivative of this term, that is 2x raised to 3 by 2 minus 3x raised to 4 by 3 minus 5 raised to 5 upon 2. Now consider this is our f of x. So f of x raised to n. What is the derivative? N into f of x raised to n minus 1 into derivative of the function. So first 5 upon 2. So keep this n power as it is into, write this function 2x raised to 3 by 2 minus 3x raised to 4 by 3 minus 5 raised to 5 by 2 minus 1. Here n minus 1. So here we write 5 by 2 minus 1 and multiply the derivative of this function. So 2x raised to 3 by 2 minus 3x raised to 4 by 3 minus 5. So again this term now keep as it is. 5 upon 2 into 2x raised to 3 by 2, 3x raised to 4 by 3 minus 5. Now we have to find the derivative of this term and here power 5 upon 2 minus 1. What is this? 5 by 2 minus 1, that is raised to 3 upon 2 by cross multiplication. 5 by 2 minus 1, so which is equal to 5 2 into 1 2 and divided by 2. 5 minus 2, that is 3 upon 2 into, now we have to find the derivative of this term. So again this term to consider constant. So raised to, again this x raised to n. So what is derivative? 2 into 3 by 2 into x raised to 3 by 2 minus 1. So this is only derivative of the first term. Minus 3 into 4 by 3 into x raised to 4 by 3 minus 1 and derivative of this 5 is becomes 0. So write again this term as it is. 2x raised to 3 by 2 minus 3x raised to 4 by 3 minus 5 raised to 3 by 2 into, now this 2 will get cancelled. So the remaining term is 3x and 3 by 2 minus 1 is 1 half. 3 by 2 minus 1. So again 3 minus 2, that is 1 and divided by 2. So raised to half. Minus again this 3 will get cancelled. So here we get 4x raised to, again this 4 by 3 minus 1 means it is 1 upon 3 and the derivative is 0. So by simplifying we write 2x raised to 3 by 2 minus 3x raised to 4 by 3 minus 5 raised to 3 by 2 into, now this 3x raised to half means root x. X raised to half means root x and minus 4x raised to 1 by 3, that means cube root x. That is our dy upon dx, which is our dy upon dx. Now third one example is there. Y equal to root plus 4x minus 7. Again this is in the form of root f of x, which is in the form of root f of x. And what is derivative of root f of x? That is 1 upon 2 root f of x into multiply the derivative of function. So again differentiate with respect to x. Differentiate with respect to x. So what is derivative of y? dy upon dx. Now derivative of root f of x, which is 1 upon 2 root of f of x. So write here 1 upon 2 root f of x. So this function as it is, x square plus 4x minus 7 into multiply the derivative of function. So what is function here? This x square plus 4x minus 7. Now again this term keep as it is, 1 upon 2 root x square plus 4x minus 7 into what is derivative of x square? That is 2x plus derivative of 4x is constant 4 and derivative of 7 which is constant, so derivative is 0. We can simplify this term. This is 2x plus 4. So we take 2 common from it. 2. So in bracket we get x plus 2 and divided by here 2 root x square plus 4x minus 7. Now this 2 will get again cancelled. So remaining term is what? X plus 2 divided by root x square plus 4x minus 7. That is dy upon dx. All examples we are solving by our first method, not by chain rule. You can solve by using any method. Now fourth one, we are going to start fourth. What is fourth? Y is equal to root x square plus under root x square plus 1. Now again this is in the same form, root f of x. Now this function is what? Whole this function. This is whole f of x. Consider this whole term as a f of x. So again differentiate with respect to x. Differentiate with respect to x. So what is derivative of y? Again it is dy by dx. Now derivative of this root f of x, which is 1 upon 2 root of x. Write it first. Root, which is function, write root x square plus under root x square plus 1. Now derivative of this function. But what is this function? This x square plus root x square plus 1, which is our function now. Now keep this term as it is. X square plus under root x square plus 1 into, now we have to find the derivative of this term. So what is the derivative of x square? That is 2x, plus sign again keep as it is. Now this is again in the form of f of x, root f of x. So again the derivative of this term is 1 upon 2 root f of x. That is 1 upon 2 root x square plus 1 into multiply the derivative of this function. So what is derivative of this function? So d by dx of x square plus 1. 1 upon 2 root x square plus again under root x square plus 1 in bracket 2x plus 1 upon this 2 root x square plus 1 again keep as it is into what is derivative of this x square? That is 2x and derivative of 1 it becomes 0. So now this 2 will get cancelled. 1 upon 2 x square plus under root x square plus 1 into, now we simplify this term, 2x plus x upon under root x square plus 1. Again by cross multiplication we rearrange this term. That is dy upon dx is equal to, the first term keep as it is, x square plus 1. Now we have to simplify the term. 2x into root x square plus 1, that is 2x into root x square plus 1 plus x divided by root x square plus 1, which is as it is. Now if we arrange this term to x in root x square plus 1 plus x divided by 2 root x square plus 1 into x square plus root x square plus 1, that is our dy upon dx. dy upon dx. Now next one, y is equal to, fifth one example is there, y is equal to root 3x minus 5 minus 1 upon under root 3x minus 5 raised to power 5. Raised to power 5. Now first we simplify this term. So how we simplify this term? By cross multiplication, we are rearranging this term. So root 3x minus 5 into root 3x minus 5. So it becomes root 3x minus bracket 5 square. Now this root and square will get cancelled. So here we get only 3x minus 5 by this multiplication. Now denominator is 1 here. So again this 1 into 1, it becomes 1, and then middle sign is minus. So right here minus. Now the denominator is what? 3x minus 5. 3x minus 5. Now it becomes 3x minus 5 minus 1. So 3x minus 6 divided by root 3x minus 5. 3x minus 5. Now which is in the form of u upon v. Which is in the form of u upon v. So now here we are going to use quotient rule. So differentiate with respect to x. Differentiate with respect to x. So derivative of what? dy upon dx, which is equal to. So what is quotient rule? Derivative of u upon v is equal to v into derivative of u minus u into derivative of v and divided by our denominator square. So use this rule here. So first keep second as it is, 3x minus 5, and take a derivative of u, 3x minus 6 minus, now keep u as it is, 3x minus 6, and take a derivative of v, 3x minus 5, and divided by the denominator square. What is denominator? Root 3x minus 5 and bracket square. Now find the derivative of this term. Therefore dy upon dx is equal to root 3x minus 5 as it is into derivative of this 3x, which is 3, and derivative of 6 is 0, minus 3x minus 6 into, write the derivative of this root 3x minus 5, which is in the form of root f of x. So 1 upon 2 root f of x, 3x minus 5, and into multiply the derivative of this function. So what is the derivative of 3x? Which is 3. And in the denominator we get again root 3x minus 5 bracket square. So again root and square will get cancelled. So the denominator becomes only 3x minus 5. Now this 3 into root 3x minus 5 minus, we multiply now this 3. So it becomes 3 into 3 minus 9x minus 6 into 3, it is 18, and divided by 1 upon 2 root 3x minus 5 divided by again 3x minus 5. Now this term again write as it is, 3 into root 3x minus 5. Now here we get minus 9x minus 18 divided by, now here we cross multiply this term, 2 into 3, that is 6, and this root 3x minus 5 into root 3x minus 5, again it becomes square of this term. So 3x minus 5 minus 9x minus 18 divided by 2 into root 3x minus 5 into 3x minus 5. So here again multiply this term. 6 into 3 which is 18x minus 6 into 5 30 minus 9x and minus minus it becomes plus 18 and divided by 2 into root 3x minus 5 into 3x minus 5. So simplify this term. 18x minus 9x which is 9x and minus 30 plus 18 which is minus 12 divided by 2 into root 3x minus 5 into 3x minus 5. So from this term we take 3 common. So in bracket we get 3 by 2 into 3x minus 4 divided by, here power raised to 3x minus 5 raised to half and here power is 1. So by multiplying half into 1, so it becomes 3x minus 5 raised to 1 half and 1, that is 1 half plus 1. So it becomes raised to 3 upon 2, that is dy upon dx, which is our first exercise 1.1. And in this exercise we see question 1 and in next lecture we are going to see question number